Hi guys, we're starting chapter 5 and it's systems of equations. This is one of my favorite chapters. We're going to start by figuring out what systems of equations look like. It's two lines put together. We're going to do graphing first. Tomorrow we're going to do the addition method and the substitution, where you'll get to pick your favorite way of solving them algebraically. Probably have a scavenger hunt, some other fun activities with it. So the first thing we're going to do is work on solving systems by graphing. So the solution to a system of the equation looks like a coordinate xy, and that would be the one thing that works. So it wants us to determine if 2, 5 is the solution to each of these systems. So basically it wants us to do a check. So we want to check 2, 5 into each equation to see if it works. So that means x equals 2, y equals 5. So we're plugging into both equations one at a time. So does 5 equal 4 times minus 4 times 2 minus 3. So 5 equals 5 here. This is doing like an auto shape. Oh. 2 times 2 plus 5. Does it equal 9? Yes. 9 equals 9. That means yes, 2, 5 is the solution. Okay, now let's do the other one. So we're plugging in 2, 5. So x is 2, y is 5. 5 minus 2 equals 3. 3 equals 3. That one works. 5 equals 1/2 times 2 plus 6. 5 equals 7. So that one doesn't work. No, 2, 5 is not a solution. My abbreviation for solution is SOLN. We can also solve these by graphing. So we want to graph both these lines. Remember to use your graphing calculator. So let's put them in one at a time. I'm going to use 2 different colors. So I'm going to do this one in pink, and I'll do this one in blue. So y equals 2x plus 5. Type it into your calculator, get some points. So on your table, you have 0, 5. You have -1, 3. You have -2, 1. -3, -1. So I graph that. I'll label this line. Y equals 2x plus 5. So we're graphing. We're extending it through the graph. We're labeling the equation a line. Then I'm going to do the other one. So this time I'm beginning at 2. My slope is a -1. You can put it into your calculator, look at your table values. Grab the ruler. We want these graphs to intersect nicely at a point. Looks like they are. We had the same point plotted on each of them, so that's awesome. So this next part, at what point do the two lines intersect? That's the part you can't forget to do. So a lot of times people graph this beautifully and they never say what the answer is. So the answer to this equation is the point of intersection. So -1, 1, 2, 3. So -1, 3. To prove that it's the solution, we can plug it into the original, do the check. So 3 equals 2 times -1 plus 5. 3 equals 2 minus -1. So check to see if this works. 3 equals 3, yes. 3 equals 3, yes. So that's how I prove that it's a point in the solution. Exercise 3 says Janelle and Swetha are taking a 50-question true-false test in their history class. Janelle started after Swetha had already finished 12 questions. So that's going to be important. Janelle answers questions at a rate of 2 questions per minute. So Janelle is 2 questions per minute, while Swetha answers them at a rate of 5 questions every 4 minutes. Once I see the words rate, what am I thinking of? So rate, we know, is our slope. Good. So rate is slope. Janelle eventually catches up to Swetha. How many minutes does it take her? And what question are they on? So minutes and what question are they on when Janelle catches up? So we have to pay very close attention to what they asked for. So let's look at our axes. The left, the y-axis is questions answered. The bottom axis is number of minutes. So we want to create 2 linear models for them. So what do we know about, let's start with Janelle. Let's just pull out the facts. So Janelle, it said that she started after Swetha had already finished 12 questions. So started when Swetha was at 12 questions. She answers them at 2 questions, so that's our slope. M is 2 questions per minute. The other girl, we know the slope is 5 questions every 4 minutes, so 5/4. So if we're looking at comparing them, if Janelle started when Swetha was at question 12, that means she starts at 0. So begins at 0. This one's beginning at question 12. So Janelle equals 2x. So we're plugging into y equals mx plus b. M equals 2. She begins at 0. So Janelle's equation is y equals 2x. Swetha's equation, plug into y equals mx plus b, is 5/4 x plus 12. So the next part wants us to graph them. So every minute, Janelle's answering 2 questions. So I'm going to graph hers in orange. So figure out what we're counting by. 2, 4, 6, 8. We're counting by 2s. So Janelle is just perfectly this diagonal. It is actually a good idea to just plot all these points, especially because we're going to be looking for a perfect point of intersection. She's perfectly on the diagonal. So we should be at a nice 45-degree angle. So this is Janelle. Excuse me. Swetha started at 12. She does 5 questions every 4 minutes. So it's up to you. I would maybe use your table and find multiples of 4. So at 4 minutes, she's on question 17. Be careful when you graph this. 12, 14, 12, 14, 16, 17. At 10 minutes, she's on question 20. 5, 6, 7, 8, 9, 10. That's not right. Sorry. Ignore that. At 8 minutes, she's on question 20. This is not working, sorry. Maybe you should just use a calculator. It's much easier. So at 0, she's at 12. At 4, she's at 17. At 8, she is at 22. At 12, she is at 27. Try again, sorry. 4, 12, 14, 16, 17, that one's right. At 8, she's at 22. 5, 6, 7, 8, 20, 22. At 12, 22, 24, 26, 27. At 16, she'll be at 32. That's our intersection point. And at 20, she'll be at 37. So this is FIFA. So the intersection point was at 16 minutes. Question 32. Graph the two equations using the calculator as needed and solve the problem. So the question said how many minutes? So it takes 16 minutes for them to be on question. What did I say? Question 32 together. All right, the next one has Zeke is racing his little brother Nico. They're running a total of 30 yards, and Zeke gives Nico a 12-yard head start. Zeke runs 2 yards every second. Nico runs 1 yard every 2 seconds. So let's see. Zeke is doing 2 yards every second. So 2 times 2 is 4. 6 times 2 is 12. Nico is doing 1 yard every 2 seconds. So we'll add 1 yard. That means that's 6. He's gone 3 yards. So now he's at 15. So we're filling out the table. Zeke's distance, so his equation, and it's time x. So what is Zeke doing? He's going 2 yards every second. So m equals 2. He begins at 0. So Zeke's distance equals 2x. Nico's distance. He's going 1 yard every 2 seconds. And he began at 12. So 1/2 x plus 12. All right, so we'll graph these. I'll use blue for Zeke. Be careful, on one axis we're counting by 2s, the other one's 1s. So 2, 2. 2, 4. 5 will be 10. 2, 4, 6, 8, 10. 10 will be 20. 15 will be 30. So Zeke is just hitting the diagonal. Pick a different color to do Nico. So he's starting at 12. He goes up. So at 2 seconds, he'll be at 13. So 4 seconds, he'll be at 14. So we would go up 1, which is really a half a unit over 2. Up 1, half a unit over 2. Let's just check. At 6, were we at 15? Yes. So this is Nico. Graph both of these equations on the grid above and determine the number of seconds it takes for Zeke to catch up from Nico. How far are they from the finish line? So how far is the finish line? So the finish line, they're running a total of 30 yards. So determine the number of seconds it takes. So it takes, how many seconds? We're right here. So it takes 8 seconds for Zeke to catch up. They are at how many yards? So they're here. So 10, 12, 14, 16. So they're at 16 yards. So they are, so how far are they from the finish line? They are, that was 30 yards total. So they are 14 yards from the finish line, 30 minus 16. All right, so on yours, you have these 4 questions to practice just substituting in, 1 straightforward system of equations to graph, and 1 multiple choice. So not too bad. All right, good luck. Ask me if you have any questions, please. The word problems on here were the trickiest, so that's why I wanted to do those for you. But good luck.